right? So what we have seen until now is we have seen this first kind of VPN called the site-to-site VPN. We did it two ways: crypto maps and GRE tunnels. The GRE tunnels, then we removed the headers, converted it into IPsec IPv4, and it became an SVTI. The difference was that this supported routing protocols. Crypto maps do not support routing protocols. No multicast traffic can go through what? Crypto maps, right? We also saw remote access VPNs. Which ones were those? We saw EasyVPN and we saw Web VPN, also called SSL VPN, also called SSL VPN. Now on the ASA, you have to understand certain things. ASA does not support virtual interfaces. It does not support any kind of virtual interface. When I say any kind of virtual interface, it does not support interface loopback. It does not support interface tunnel. It does not support interface virtual template. All these features are not supported by the ASA. If they are not supported by the ASA, which means on the ASA, you will not be able to use your SVTIs, you will not be able to use your GRE, you will not be able to use your DMVPN, your Get VPN. You will not be able to use all of these, right? Most predominantly, we don't use ASA for this. Now GetVPN works on crypto GDOI. Doesn't work on interface virtual templates. But most predominantly, when you're using this, when you're doing all these VPNs on the ASA, right? Most predominantly it used for two. One is site-to-site VPN. The other one is this SSL VPN. You've already done. You've already seen how SSL VPN works, right? So we know how it works on the ASA, how it works on the iOSs. Now we want to see how EasyVPN works on the iOS, the ASA and a site-to-site VPN. What are the differences between a normal site-to-site VPN on the router and ASA? So what I'll do is I'll have two different ends. Both of the ends, I'll have one end will be iOS, the other end will be ASA. The thing for you guys is you don't have to know the theory now. You know the theory already. It's just the implementation on the ASA, the commands on the ASA. The theory remains the same. The total number of packets exchanged remain the same. In ISACAMP, 9 packets. In IPsec, the normal, all the data packets will go through. There will be no difference. Okay, let me create the topology. The first one that we are going to do is site-to-site crypto maps on the ASA. Okay, let's go ahead and do that. So this is going to be the topology that I'm going to be working on. This is going to be the internet. So let's give out public addresses from the internet to the edge. Let's say this is 20.0. Let's say this is 23.0. Right? And this is going to be the internal network. So 10, 11, 11. Let's use this. That we know that ASA is the edge right now. And let's start it out. Now, R1 is going to be the internal network. So it can be a server inside, it can be users inside, doesn't really matter. My job is to encrypt traffic coming from 10, 11, 11, 0. Going to, let me Just change the style here. Coming from 10.11.11.0, going to another loop back here, 10.3.3.0, because R3 is another edge, right? R3 is going to be another edge. Job will be to do something like this. Protection from 10.3 to 10.11 through your internet. Right? Let's do some basic configurations starting from R1. R1, R2, R3, matrix. A default route pointing towards the firewall. Correct? The internet 20.2 23.2. No need a route on this. Finally R3, a loop back. .23. A default route 23. Correct. So R1, R2, R3 are done. The only thing left is the ASA. Interface Ethernet 1, 10.11.11.10. No shut, name it. Inside. IP address is 151.20.10. So name it. Show interface IP brief. Good. And also need a default route pointing towards the internet. My basic connectivity should be from here until R3. First packet dropped because of R. Everything else is okay. I can reach from ASA to the router, the edge router of the other side of the company. So two different sites of the same company. I need to connect them up together. A normal crypto map tunnel. Do you remember how to create it? What were the steps? The first was the policies. Crypto ISA policy 10. Encryption 3 days. Authentication B. Share hash MD5 group. The second is the validation key, only used for, it's not used for encryption, it's not used for anything else. What else is it used for? Only for validation of the pair. 151.20.10, the ASA is public address. Correct? Step 3 is the transform set, crypto, IPsec, transform set, T set, ESP, T des, ESP, D5. Step 4, access list, 101, permit IP from which host? Not host, from the network 10.3.3.0 to 10.11.11.0. This is not the ASA, so this will be a wildcard mask. Correct? Step 5, bind all of these things together in a map. Crypto, map, IMAP, 10, IPsec, ISACAM, set peer, 151.20.10, set, transform set, T set, match, address, and interface FA00, crypto map. Any questions? This is basic stuff, right, on the iOS. Copy it on R3. Done. ISACamp is on. Let's go ahead and see what are the differences between this and that of the ASA. Right, so this becomes your iOS, the 6 steps on the iOS, and we'll move down, do it for the ASA. Policies. I need to find out a way to tell ASA which policies to use. Correct? I have to do that. What there is, you have done web VPN already on the ASA. What ASA has is there is a streamlined procedure. So if you do one VPN and you know how to do it, the others become relatively easier because they use the same process. Okay, so you just have to learn the process once. Then others are just revolving around the same concept. Right? Let's see what that concept is. First things first, step 1 remains the same. You still have to specify the policies. So what you'll do is you'll go to R1, not R1, sorry, the ASA. Sorry about the sound. Right, so I'll go to the ASA, crypto, ISACamp policy 10. It requires a key. Let me give it a key. So it's up. Let's go ahead and do that. Crypto, ISACamp policy 10. Same. Encryption 3 days. Authentication 3 share. Hash MD5. Group. Okay. So the first step is the same. No difference. The second step is different. What they've done is, because you use EasyVPN and all the other kind of web VPNs in there, so what they've done is for the pre-shared key they used a separate mechanism. Because remember, in the iOS the way to do it for EasyVPN is entirely different. To specify the group and key for EasyVPN is entirely different than you do it for the iOS. iOS is simple, one command. iOS is only one command. And in group and key, you have crypto client, ISACamp client, configuration group and key and username and password and stuff like that. So it becomes more complicated. Here that is not the case. Here they have made a simple procedure which both follow, site to site as well as easy. It's called tunnel group. Tunnel group, and you specify the IP address of the peer here. Although it says word, it says you can give it a word, but what you basically have to do in terms of site-to-site VPN is you have to specify the IP address of the peer. What is that IP address of the peer? 23 dot. And there's only one option, type. What kind of crypto map or what kind of tunnel are you creating here? There's only two. One has been deprecated. You don't use this one anymore. So it's either a LAN-to-LAN tunnel or a remote access tunnel. Okay. Which one am I doing right now? IPsec L2LV. Site to site, right? So the first one. Now check this out. Tunnel group. I'll go in again 151.23.3. Now I won't get the option type. I get general attributes and IPsec attributes. The difference between general and IPsec attributes is when you specify the key, or you have to specify a trust point for RSA. There's two things, right? Either you specify a trust point for RSA or you specify a key. That is done in IPsec attributes. General attributes will be stuff like address pools that are supposed to be pushed down. It will be network extension mode on or off. It will be some other split tunnel ACLs which are supposed to go down. Right? That is done where? In general attributes. Your key, this key. Which key? This one right here, the pre-shared key, or if you're using RSA. In both cases you'll use IPsec attributes. And when you press question marks, you get the option of pre-shared key. What is the pre-shared key? The one which I use on the other end is. So this step 2 is different. Step 2 is not the same. Step 1 is the same. Step 2, it's tunnel group, right? 151.23.3, then type IPsec LTL, and again tunnel group 151.23.3 IPsec pre-shared key. Okay. Step 3 is the same. IPsec transform set, tset, ESP, 3res, ESP. Okay, so step 3, no difference. Just copy it. Step 4, do you think it will be different? It's an access list. So access list will also be the same. Step 4, access list will be access list 101, let's say. Permit IP going from 10, 11, 11, 0. Now this is an ASA, so not a wildcard mask but a subnet mask. Going to 10.3.3.0, 255.255.255. The last step is different. The last step is different. What do I mean by difference in the last step? Now, do you remember the difference between, I always use this example because I think it's the easiest to understand. Do you remember the difference between, let's say I create an ACL 101 and I say permit IP from host to any, and I say deny OSPF any, I say permit IP any, or I do this access list 101 permit IP from host. Are these two access lists different? They work exactly the same way. They work exactly the same way. They are not different at all. It's just the implementation is a little different. Why? Because here I need to, for each step I need to write access list 101 because it's not a subheading mode. In extended ACLs I have subheadings, right? So I am already under the access list of 101. So whatever I do will be added to 101. Here there is no sub modes, right? No sub configuration modes. So what do I have to do? Every line I have to put in access list 101 and then specify the same lines which I do here. The same concept applies to crypto maps. Earlier when I did crypto maps, you see it was all under what? A sub configuration mode. On the ASA it doesn't support the sub configuration mode. You have to do it separately. That's the only difference. Crypto map IMAP 10 set peer. Crypto map IMAP 10 set transform set. Crypto map IMAP 10 match. Okay. Crypto map IMAP 10 set transform set reset. Crypto map IMAP 10 set here 151.23.3. Crypto map IMAP 10 match address, right? So step 5, which was this, now becomes this with no difference. It's just that now crypto map 10 you'll have to write it down everywhere. Step 6 was interface F00 crypto map. Here to apply it to the interface is even easier. You say crypto map IMAP without the number, you say interface right. So crypto map IMAP interface. Now see, remember I told you when we were doing ASAs, I told you that These outsides, inside, they are case sensitive only for certain commands. They are case sensitive. If I do this, he's telling me what? There is no such interface as outside. Why? Because when I configured outside, the O was not all the commands. Most of them are not case sensitive, but some are. So best practice is that you keep your typing case sensitive. Always make sure that you know your O is capital, so use O as capital. Okay. The last thing, see, everything is done. Step 6 is done. On the ASA, there is one extra step. Why? Why an extra step? Do you remember to and through traffic on the ASA? Through traffic was controlled how? Through traffic was controlled using security checks, ACLs, and so many different things. How about to traffic? How did we control to traffic on the ASA? Say for example, I wanted to telnet into ASA. I would have to permit that service on that interface. Remember, by default, only ICMP is the only service which is enabled by default on the interfaces. So everybody can ping to the ASA. Right? Telnet is not allowed. SSH is not allowed. To allow these services, what do? You allow it. Telnet. I want to allow telnet from 10.11.11.1, for example, with a mask of 255 as a host and on the inside interface. So then telnet gets allowed as a service on that to traffic, right? On that interface. The same thing you have to do for what? Because now when you're creating this tunnel, you're creating a tunnel from R3 to the ASA. So you'll have to allow that service on the ASA's interface. That service is crypto ISACAP UDP 500. Enable on which interface? Do not forget this command. Because if you do, everything will be perfect, but this will not work because your service is not enabled on the outside. So whenever you're doing this, keep a habit of crypto. Keep a habit here. In the 6th step, use 2 commands. Applied, the moment you apply it on the interface, during, you should know that you have applied it, you have to enable the service. Otherwise it will not. Good. Let's try and see if this is working. We'll go from R1. Do I have a route? I should have a default route. I do. I'll ping 10.3.3. Right? Ping is successful. Ping is successful, right? Let's go to R3. Show crypto ISACAP. Show crypto IPsec SA. 3 packets have been encapsulated and decapsulated. You can see the whole thing if you want to. 10.3. The 2 endpoints are, the local identity is 10.3, the remote identity is 10.11.11. Port, right? Port 500. I'm using 533. Packets have been decaps. Sorry, the local endpoint is 23.3. The remote endpoint is 20.10. Inbound SA and outbound SA. There's nothing different. It's exactly the same. You don't see a difference. If you want to see it here, let's actually do this. Let's start Wireshark. Verification commands, everything. I'll show it to you on the ASA also. I want to show you right now the process layer crypto ISACAP. I want to show you the process. How many packets? The same 1, 2, 3, 4, 5, 6, 7, 8, 9. Same 9 packets of ISACAP. Do you see anything different? Nothing. It is exactly the same. Right? It's just that the implementation was a little different. The process, the protocol is no different. Let's see on the ASA. How do you check it? Show crypto IPsec SA, the same SA. It is exactly the same SA. It shows you what access list you're using, the proxy ACL. Shows you your remote local endpoint is this. You're encrypting from 10.11.11.0 to 10.3.3.0. 4 packets have been encrypted, 4 packets have been decrypted, and your local endpoint, remote endpoint, your media, in and out SA. No different. Okay. Only thing is, show crypto ISACamp SA doesn't show you QM idle. It shows you main mode active, the state. It's not called QM idle anymore, and the way it's displayed is a little different. Why? Because it tells you that this is a type L2L tunnel, right? Then your peer is here. You were the responder, you did not initiate the connection, and I think there is detail also. Yeah, the remaining lifetime is here. The authentication you're using is the pre-shared key. Encryption is 3 days. This is for what? The first tunnel. The first tunnel is using all these parameters. It's just the display. The way the packets work are exactly the same. Okay, is it clear? Another thing that I want to show you is, say for example, right now whatever traffic is going through the tunnel, when it decrypts on the ASA, is it checked for anything? Is it checked against security levels? It's not. Is it checked against ACLs? ACLs it would be. It would be, but right now, say I'll do it here. I'll go to the ASA and I'll say crypto access list INF deny IP any access group INF in interface. Tunnel traffic still works, even though ASA right now is saying what? Deny. So whenever the traffic is coming in, it does not go through which checks? Your security level checks, your ACL checks. It goes straight in to NATing. If you remember the boxes, I don't have the pen right here. There are 4 boxes, right? The connection table and all of those other things. It goes through the connection table. It goes through the ACL. It goes through the security level check. No one checks it. Registered, decapsulates, does NATing, routing, and goes out. Right? How do we not do that basically? I want my VPN traffic to also be checked when it's coming in against all the checks. Let's remove this access list first. For that, check your running configuration. In your running configuration, by default, there's a command which says sysopt connection permit VPN. Now sysopt is a command that is used to change the default behavior of a firewall. You can use it to change some other stuff also, maximum segment size, connection wait times, different things, TCP intercept. Right? Right now, what I want to use it for is, I want to disable this feature where VPN is permitted. Traffic coming through the VPN is permitted to go through the checks. Right? Let's try now. The packet is stopped. Why is it stopped? Because the lower security level guy is trying to go to a higher security level. How do I allow it? An access list. Access list INF permit. Do I allow public to public or private to private? Private to private. Because it gets decapsulated. There is no problem with decapsulation. After decapsulation, it's checked. Checked after decryption and decapsulation. So let's say I'll permit ICMP from 10.3.3.0 to 10.11.11. Okay, and I'll apply it where? In interface. Let's try now. My ping works. But do you think my telnet will work? Telnet will work? will not work. I only permitted what? ICMP from out to in. From the private of out to the private in, but I only allowed what? Ping. Through, even if it's coming through the tunnel now, it still is not the same. It's still getting checked against the other stuff. Right? Same thing I'll have to do to allow telnet. Access list INF permit TCP from host 10.333 to host 10.11.11.1 equal to 20. Good. This is called what? Sysopt. Either you can allow it or you can disallow it, depending upon the company's need. If you want extra security, higher security, if you want to check even the traffic that is coming through the VPNs to the firewall, you can do it using this. Good. The last thing is, let's say on the ASA, I have, now this is only one host, 10.11.11.1 is only one host, right? There will be another, say 255 out of 255, let's say 200 people on the network 10.11.11.0/24, for example, right? They need to go to the internet. What do they do to go to the internet? They NAT, ASA NATs for them so that the users inside can access the internet, right? Normal NAT. How does he do that? ASA global outside one, say interface, NAT inside 1, 10 say 000. Correct? So all 10 users will be able to go to the internet and can translate it. Do you think now my ping will work? It doesn't work. Can anybody explain why? Check this out now. How does encapsulation process begin? When from 10.1 this traffic coming from 10.11.11.1 going to 10.333 comes into the ASA, gets routed, sees a default route, tells him you have to go to the outside interface. The moment it hits the outside interface, exactly this traffic, then the crypto map is triggered. Now I'm doing NAT. When my packet is going through the ASA, what does NAT do? Changes this part to 20.10. When it hits the outside interface, is it the same? Will it trigger the firewall? Will it trigger the crypto map, I mean? It will not. It does not match the proxy ASA. For this to work, you have to exempt. Remember NAT exemption? You have to exempt which guy? The one which you're creating the tunnel for. 10.11.11, say 1. There's only one guy you want to do it for. This is the server which people from outside are accessing. So what you'll do is for 10.11.11.1, you'll say no translation is required for this guy. Right? How do we do that? If you remember, identity NAT is done with the help of an NAT exemption is done with the help of an access list. So I'll say no NAT, right? Permit IP going from 10.11.11.1 host going to and NAT inside 0. Access list is what? If you check your show NAT, you'll see that this one is given a higher preference. NAT exemption is given a higher preference than a normal NAT. Right? So even if you're running configuration, NAT 0 is given a higher preference. Not NAT 0. NAT 0 with an access list. Access list is the most specific kind of traffic. Access lists are always given a higher preference than your matching statements. Right? Now let's try. Starts working. Correct? Because now there is no translation happening for your traffic. Is this clear? site-to-site VPNs, right?